Hello. First of all, I would like to apologize for my English. It's my third language. I will try to explain everything that I done in this homework in a very clear fashion. So, let's start. If we have a ball on a horizontal plane and it is still two forces are acting on it, force of gravity and opposite force of normal force of the surface. These two forces are equal in length but opposite in direction. If we sum these two vectors, we get zero. First Newton's law states that if sum of forces on a body equals zero, or if there are no forces, then this object will be standing still, or it will move with constant velocity. If it moved at constant velocity in the start. With the second Newton's law, F equals m times a. That means that acceleration is proportional to the force or sum of the forces acting on a body. In our case, the sum of the forces equals to zero, so there is no acceleration. If there is no acceleration, then the body moves at constant velocity. Here I use second Newton's law to prove that. Okay. Now let's start with our experiment. So here is our experiment. The ball will move from right to left, and I will put the positive x direction in the same direction that ball moves. Here I put some ruler to specify the length in the video. I'll hide this. So let's see. Okay. I put here the center of the mass, and with every frame of the picture I define that center of the mass, and here are the time and position numbers for that moment. Mass of the ball is equal to 0.43 kilograms. Okay, let's see that again. Okay, here we have a graph at this moment. Okay, let's experiment. With these numbers, I calculated with two sets of numbers. I calculated the velocity. So velocity equals to difference in position, accordingly difference in time. I get 0.878 meters per second, and The rate of the frame is shown here. It's 0.042 seconds. Okay. Then I made a theoretical model in Python. So my experiment lasted like a little more than 1 second. Okay, I put in this in here. Then force is equals to 0. Ball velocity is constant because forces are 0, so this second term in this formula is 0. Ball position, we calculate by this formula, and t equals to t plus delta t. Okay. Oh, let me start this, run this. So let's see what we get. Okay, let me try this again. Okay, so let me run this again. So you see ball moving to the right this time. This is a graph of constant velocity of okay. And now let me compare these two things. Here we have experimental position versus time. This is shown in blue, and in red it is shown model position versus time. We have a graph of this. We get we confirmed that experimental and model position are compatible. We proved experimental numbers with model numbers. Let me see. Okay, at the end here, model position differs from the experimental because there is some friction, perhaps. There is some friction, yeah. And that's that. If we moved positive x direction to the other side, then the graph would be like line, but here, like in this, let me see, the same slope in this direction. Okay, that's all for the first time. Thank you.